transfer between two systems, okay? System A, system B. What is the new U total when these two things come together? Total energy of A is 10. It's a 0 plus a 1 plus a 2 plus a 3 plus a 4. Here we have 0 times 3 plus 2 times 1 gives us a total energy in B of 2. So when we put these two things together, what will be the new U total? 12, right? Conservation of energy. That's my only choice. And then these are three different configurations, okay? What does that mean? What do these three different configurations represent? Microstates. These are different microstates of the same macrostate. The macrostate is 10 particles, total energy 12. Okay? So if you have two things that have the same total energy and the same total particles, then you have two, but they're ordered differently. The energy distribution looks different. They're still two microstates of the same macrostate. Okay? Same total particles, same total energy. Okay. What is the Q indicating? Heat. So when these two things come in contact, there's going to be some sort of heat flow between them. Remember, we were talking only about kinetic energy, okay? So these things are bouncing and gonna run into each other and exchange heat until there's no net change in heat flow. They reach equilibrium, okay, after a sufficient amount of time. So this state here that has higher energy, okay, has 10, is a higher temperature than our lower energy state. When they come in contact, heat will flow from the higher temperature into the lower temperature. The energy will be transferred through the collisions between the molecules, okay, until they reach some final temperature. And then just keep in mind that in reality we have both kinetic energy and potential energy, and right now we're just exclusively talking about kinetic. What's the multiplicity of the combined system at equilibrium? So let's start by, what is the multiplicity of A for this one? How do you go about doing that? Just side A. What goes on the top? A number goes on the top before the factorial? 10. What goes on the bottom? 2 and 8, okay? So the multiplicity of A is 45. How about for B? It's still 10. 6 and 4, okay? What is the combined multiplicity of this system right now given this information? Forget the words at equilibrium. And multiply them together, right? And I get 9450. No. Right now, stop and go. If I asked you the combined multiplicity of putting these two things together, this is how you would do it. You would just multiply them. Now, if you let enough time go by, they would rearrange themselves in order to maximize multiplicity. Okay? And that's what equilibrium is here. So they could organize themselves something like this. This would actually make multiplicity worse, so it wouldn't probably do this. Okay? So total energy in available levels stays the same. We still only have 2 energy levels that they can get into. We still have 10 total molecules being contributed from A and B. But given sufficient amount of time, the system would try to maximize entropy by making the highest possible multiplicity. Okay. The maximum entropy of a combined system after heat exchange occurs when equilibrium is reached.